everyone. So we are gonna kind of extend off of yesterday's. So yesterday, remember, we were kind of solving logarithmic equations, and we were always solving problems like this. So it was always what this thing equal is. Okay, so we're gonna go ahead and do a couple of examples like that as a warm-up. So we want to know in this first one what log base 7 of 49 equals. And if you remember back from yesterday, what we did is we got this in exponential form. That is a form we are familiar with. And we got it into exponential form by doing a log roll. So remember, we always start with the base, what it equals, and what's left. So another way I could write this in exponential form is 7 to the power of x equals 49. And then maybe right off the top of your head, you know that 7 to the blank is 49, and you know right off the top of your head that x equals whatever. But another way we could do it is we could also get our same bases. So 7 and 49, I can use a base of 7. And 7 squared will give me 49. And now that my bases are the same, I can set my exponents equal to each other, and I get x equals 2 as my answer. So this whole thing, log base 7 of 49, just equals 2. Let's go ahead and do another one like that. So again, we're solving for the exponent. So again, I'm going to get it into exponential form by doing my log roll. So starting with my base, it's all about that base, And when we put this into exponential form, I'm going to have 5 to the power of x equals 625. And again, maybe you know right off the top of your bat what x should be. Otherwise, we can do our same bases. I think it's 5 to the 4th gives us 625. Yep, I just gave it a video. So again, if I make my same base, I know another way I can write 625 is 5 to the power of 4. And now, since my bases are the same, we can set the exponents equal to each other, and I get x equals 4 as my answer. All right, so this is what we did yesterday. You'll see a little bit more of that today, but in these ones, we were always solving for the exponent piece. Okay, today I'm going to move the variable around on you guys then. So notice this next set, what we're going to be solving for is the argument in this logarithm piece. Okay. Our process is still going to be kind of the same though. First thing we're going to want to do is get it into exponential form by doing our log roll. So I'm going to go ahead and start with my base and do my log roll. So when I write this in exponential form, it will be 81 to the power of 3/4 equals x. And now I just need to evaluate this part. Remember, another way I could write this is as a radical. So exponent over index. So let's see, let's think about this. What is the 4th root of 81? And hopefully you guys are coming up with 3. And then 3 cubed then is 27. So log base 81, of 27 equals 3/4. Let's go ahead and do another one. So this next one, we have log base 5 of x equals -2. Again, first step, we need to get it into exponential form. So this would be 5 to the power of -2 equals x. And now again, we just need to clean this up. So let's see, we know negative exponents make things flip to the bottom. So I'm going to go ahead and flip that first. And let's see, 5 squared is going to give us 25. So log base 5 of 1/25 will give us -2. All right, so there's when we're solving for the argument. Last type then is when we are solving for the base. I think I'm going to do this one first. So we have log base x of 64 equals 2. Again, first step, always get it into that exponential form. So I'm going to have x squared equals 64. And now in order to get that square root of, I'm going to take the square root of both sides, and we will get x equals 8 for our base. So log base 8 of 64 equals 2. And if you think about it, if we put it back in and do another log roll, 8 squared does indeed equal 64. All right, see this one over here now. So log base x of 9 equals 2/3. Again, we need to get it into our exponential form. So we'll have x to the power of 2/3 equals 9. Ooh, check it out. This is what we did in our radicals unit not so long ago. I'm going to rewrite this as a radical again. So remember, it's exponent over index. So first thing I'm going to go ahead and do is cube both sides. See, 9 cubed is 729. And over here, our cubed and our radical are going to cancel out. And now we need to go ahead and take the square root of both sides. I do not know what the square root of 729 is off my head. It's 27. So log base 27 of 9 equals 2/3. All right, so they're solving for each of the three pieces, for the exponent, for the argument, and then the base. There's one other thing I want to show you guys today. And that is what we call the common log. So when we do like square roots and stuff, we know we don't write it, but we know that that index number is a 2. Same thing as if we were to write like 5 times x. We know the exponent on that x is a 1, but again, we don't write it. Okay, and there's a few other things in mathematics like that, whereas we just know what that number is, but we don't write it. Okay, so in terms of the common log, notice I did not write a base when we have just a log like that. That is another one of those situations, and when we don't write the base, we again call that the common log. And when it's not written, we know the base is a 10. So these two things mean the same thing. Log base 10 of x is just log of x. So when the base isn't written, it is applied that is a base of 10. And that is also what your calculator uses as well. I'm sure some of you have noticed a log button on your calculator, but it doesn't give you the option to change the base. Your calculator is using a base of 10. All right, back to these ones. So there's going to be a couple on your homework tonight where the base isn't written, but again, we call those a common log, and it is implied that it has a base of 10. So if I were to solve log of x equals 2, I'm going to do the same thing. I know that even though the base isn't written, we have a base of 10. I'm going to go ahead and do my log roll to get it in the exponential form. And look at that. X is 100. 10 squared is 100. All right. This one over here might be a little tricky. Again, I know my base is 10 again because it's not written. And when you guys are doing this problem, it might help you to convert 0.01 into a fraction, which is 1 over 100. So all I did in this step is convert 0.01 into a fraction. And now same thing, I'm going to go ahead and do my log roll. I don't know what x is off the top of my head, so I'm going to go and try and get the same base. So let's see, I know I can write 100 as a base of 10. So 10 squared gives me 100. And I need to add that negative in there because it was flipped. And now look at that. my bases are the same, so I can set my exponents equal. We get x equals -2 for our final answer. All right.